Hello everyone. Now let us take a look at a question of math which came in JEE Advanced 2017. The question says, it is a passage question. Let f of x is equals to x plus ln x minus x ln x for the domain of x values 0 to infinity. Column 1 contains information about the zeros of f of x, f dash x and f double dash x. Column 2 contains information about the limiting behavior of f of x, f dash x and f double dash x at infinity. Column 3 contains information about the increasing and decreasing nature of f of x and f dash x. So let us write down what we have been given. F of x is equals to x plus ln x minus x ln x for the domain of values 0 to infinity. Let us find out f dash x, which is 1 plus 1 upon x minus, using chain rule, plus 1 upon x into x, which is 1 upon x minus ln x. Let us find out f double dash x, which is minus 1 upon x square minus 1 by x, which is nothing but 1 upon x plus 1 upon x square. Okay. So since we need to analyze a lot of options in this question, since this is a passage type of question, we might consider drawing the graphs of these functions and analyzing them, and then finding out the correct option. So let us try drawing the rough sketch graph of f of x. Now f of x, now the functions, we need to analyze these functions around the points of x, such as 0, 1, e and e square. So let us try finding out the values of the function around these values, around 0, 1, e and e square. So yeah, let's start. Let us say find out f of 1, which is 1 plus 0 minus 0, which is 1. F of e, which is e plus 1 minus e, which is again 1. F of e square, which is e square plus 2 minus e square into 2, which is 2 minus e square, which is less than 0, right? So yeah, 1, this is f of x equal to y. 1, at 1 it is 1, at e it is 1, at e square it is a negative value, which is 2 minus e square. So yeah, the function will pass through these points, this and this. Okay. Let us start with column 1. Column 1's first option asks you f of x is equals to 0 and for some x 1 to e square. F of x is equals to 0 for some x 1 to e square. So yeah, so the function has a positive value in this portion and negative value in this portion. So from 1 to e square, it changes its nature, which is from positive to negative. So definitely, since it is a continuous function, it definitely crosses 0 at some point between 1 to e square. So yeah, first option is correct. F dash x is equal to 0 for some 1 to e, for x 1 to e. Now for this to solve, we might need to analyze the graph of f dash x. So f dash x has two functions basically, 1 upon x and ln x. Let us draw them. The graph of 1 upon x is like this, 1 upon x, and the graph of ln x passes through 1 here and becomes 1 at e. So yeah, the ln x graph looks like this, right? X-axis, y-axis. So yeah, this is ln x, this is 1 upon x. So we can clearly see that the ln x and 1 upon x value is only equal at this point, between 1 to e. And since they have a negative sign in between them, we can say that f dash x is only 0 at this value, since the functions ln x and 1 upon x is only they only have an equal value at only this point, right? So f dash x is only equal at this point from 1 to e. And we can also see that ln x is far greater than 1 upon x in this portion of the graph. And since ln x has a negative sign in this function of f dash x, we can say that f dash x will be negative in this portion of the graph, and vice versa, f dash x will be greater than 0 in this portion of the graph. So yeah, that's about it for f dash x. So for column 1, second option, it says that f dash x is equals to 0 for sum 1 to e. So we can clearly see that f dash x is equals to 0 for 1 to e. So second option is correct. Third option says that f dash x is equals to 0 for some x 0 to 1, which is not correct because f dash x is only 0 at 1 to e, and from 0 to 1 it is always greater than 0. So third option is incorrect. Fourth option in column 1 says that f double dash x is equals to 0 for some x 1 to e. Now f double dash x is this value, right? Now for all the positive values of x, which is the domain of this function, all the positive values of x, we can see that this value will always be positive. And since this positive value, forever positive value, is multiplied with a negative value, this f dash x will always be less than 0. Not even it will be equal to 0, it will always be less than 0. So fourth option is incorrect. Column 2. In column 2, they ask limit of the functions. So limit of f of x for x tending to infinity. Now let us look at the graph of f of x. Yeah, so f of x, f dash x is greater than 0. So from 0 to this point, so from 0 to this, whatever point this is, the value of f dash x is greater than 0. What does it mean? It means that the function f of x is increasing. So since it is increasing and it passes through here, so yeah, at here, so for this portion of the graph it is decreasing because f dash x is negative. So like this, and it goes on. Okay. So as we can see, for x tending to infinity, f dash x goes towards minus infinity. So yeah, first option is incorrect. And the second option, which says that it actually goes to minus infinity, is correct. Third option in column 2 says that for x tending to infinity, f dash x will be minus infinity. For x tending to infinity, f dash x will be minus infinity. Now f dash x, as we can see, is negative in this portion of the graph, and it will keep going on in the negative direction because ln x is forever increasing with the negative sign, right? Ln x is forever increasing with a negative sign. So this portion will go towards infinity because this particular ln x will go towards minus infinity. So yeah, third option is correct. Fourth, limit f double dash x for x tending to infinity is equals to 0. F double dash x for x tending to infinity. When x tends to infinity, 1 upon x plus 1 upon x square. What happens to these functions? This obviously goes to 0 and this also obviously goes to 0. Multiplied by any sign, even negative, it will tend to 0. So yeah, fourth option is also correct. Going to column 3, we have column 3's first option, which is P, says that f is increasing in 0 to 1. So for f to be increasing in 0 to 1, we should have f dash x to be greater than 0. So f dash x is greater than 0 from 0 to 1, and f is increasing from 0 to 1. So yeah, option P is correct. Now for option Q says that f is decreasing in e to e square. F is decreasing in e to e square. Yes, it is decreasing in e to e square, and f dash x is also less than 0 from e to e square, right? It is decreasing, so Q is also correct. Now our option says that f dash x is increasing in 0 to 1. F dash x is increasing in 0 to 1. Now f dash x. Now for f dash x to be increasing, its derivative, which is f double dash x, has to be greater than 0, right? Now we've already seen that f double dash x is forever negative in this question. So this means that f dash x is forever decreasing in this question, right? So since f double dash x is forever less than 0, we can say that f dash x is decreasing. Yeah. So option Q, increasing, it never increases. So now option S says that f dash x is decreasing in e to e square. So it is forever decreasing. So yeah, in any domain it will decrease. So S is correct. Now option A, column 1, column 2, column 3. Option A's combination is 2, 3, S. B, 1, 2, R. C, 3, 4, P. D, 4, 1, S. Now, okay, so first option says that 2, 3, S. 2 is correct, 3 is correct, S is correct. So A's combination is correct. B says that 1, which is correct, 2, which is correct, R, which is incorrect. So this is incorrect. Option C, third, incorrect. Option D, fourth, which is then again incorrect. So we have the only one correct combination, which is option A.